Hello, my name is Parth Shukla and I live in New Jersey, and my mentor Natalie helped me with the project in which I did a quantitative study of robotic arm limitations for assisting physically impaired individuals. The reason I wanted to study robotic arms is because I thought they're pretty interesting, and I think that if I could improve it, that'd be pretty amazing. My research rationale was that robotic arms are widely used in factories, farms, and warehouses, but they're mainly used for picking up one specific object in pick and place tasks. Efficient design that enhances the robotic arm to pick up multiple objects could revolutionize daily life and offer greater support and independence for physically impaired individuals. My research question was, what is the most effective gripper attachment for optimizing the efficiency of a robotic arm when handling a variety of objects? So an optimal gripper attachment would have grooves/spikes, indents that are circular or hexagonal, and an increase of mass overall. The materials and build I used for my project, at least the main ones, was that I used the OWI robotic arm kit and a 3D printer and filament that I used for my designed gripper. I built the kit with instructions, and I designed my gripper using Tinkercad. My designed gripper has grooves/spikes, and it has a hexagonal indent. My designed gripper can attach to the robot as seen in the bottom left. So experiments, how did I test my object? Well, I used these supplies, which is OWI robotic arm, 3D printed gripper, Play-Doh discs with variation in size and weight. So if you go to the bottom right, then the 15-gram disc and moving to the left varies in size and weight, while the Play-Doh disc with no variation in size and weight moved from 15 gram to the 150 gram on the right side. So the small cup, car keys, and empty normal size wallet was for one of my experiments. First experimental procedure, I assessed the robotic arm's abilities to pick up and hold three different Play-Doh discs, which had varying dimensions, varying sizes overall, and varying weights. And the independent variables was the weight of disc, gripper type. Dependent variables was the success/failure of holding the objects and how long it could hold each object. These discs were placed near the robotic arm gripper. Then I used a controller that I was given along with the kit, and I picked it up and suspended it off the ground by 1 foot, and I started a stopwatch to time it from anywhere 15, 60, and 120 seconds. So the results of this experiment are shown in the table I have on the left. As you can see, the kick gripper, which is on the top three charts, failed at holding the 150-gram disc over 60 seconds twice, failed holding it above 15 seconds once, while the designed gripper, which was able to manage the variation in disc weight and dimensions, failed 4 times less and failed at the 150-gram disc, holding it above 60 seconds in weight trial 3. So it's better as it's more effective, and I can conclude that. For procedure number 2, I assessed how it could hold objects of varying weight and same dimensions. Once again, I suspended them above the ground by 1 foot, and the independent variables of this experiment was the weight of the cylinders, the gripper type. So the results of this, shown in the table, was that kick gripper failed holding the 150-gram disc up to 60 seconds once, and it also failed above 60 seconds twice. Another failure of it was 75 grams, and it couldn't hold it for above 15 seconds in weight trial 2. The designed gripper, on the other hand, was able to hold it for above 60 seconds 2 out of 3 times. So therefore, the kick gripper failed 6 times as many metrics, and it struggled in changes with the disc weights. And the design gripper, on the other hand, was more effective at holding your discs for longer periods of time. For the third procedure, once again, lift 1 foot above the ground, and I assessed the robotic arm ability to hold and pick up 3 different common household objects, which was an empty wallet, 56.7 grams, car keys, which was 78.8 grams, and a small cup, which is 41.6 grams. Independent variables would be weight, geometry, and dimension of the object, along with gripper type. Common household objects, the results of this experiment was that the kick gripper was able to pick up the keys for above 15 seconds once, and not able to pick up the keys for more than 15 seconds once, along with failing at the wallet for above 60 seconds. On the other hand, the design gripper only failed on the keys for picking it above 15 seconds 1 time out of 3. and the kit gripper failed 8 times as many metrics, so therefore making the design gripper more effective at holding objects with varying weights and geometries. The conclusion I reached at the end of my experiments was that my design gripper has proven that it could pick up items of varying geometries, dimensions, and weights better than the kit gripper. The Common Household Objects experiment was a vital test to prove that this design gripper can assist individuals with lower motor control. Thank you.